In this video, I'm talking about how to create an effective chatbot for interview. My name is Ziang. I'm from the University of Illinois at Urbana-Champaign. I completed this work when I was an intern at GG. It is a joint work with Xiao, Wenxi, Huahai, and Changyan. In the past few years, we all witnessed a chatbot tsunami. Through a text-based conversation, chatbot has been adapted for a wide variety of applications. For example, designing AI chatbot as a teammate, where the chatbot can learn team characteristics and help teaming. People design AI chatbot as customer representative as well, where the chatbot answers a customer's question and provides solution. AI chatbot has also been created as academic advisor to engage with students and help them throughout the semester. Among various chatbot applications, a prominent one is information elicitation. Interview chatbots engage users in a text-based conversation to draw out their views and opinions. Both researchers and practitioners have been used chatbot to engage with their target audience and draw out insights. Besides the benefit of scalability, recent studies also shown that using an interview chatbot can not only elicit rich and truthful information, but also deliver an engaging experience. However, building an effective interview chatbot is not an easy task. We are facing many challenges. Understanding user natural language input is difficult, especially when open-ended questions are involved. Users may give highly diverse, complex, or even ambiguous answers as shown on the right. Second, the chatbots need to handle complex conversation situations. Natural language conversations are nonlinear and often go back and forth. Users might ask clarification questions in the middle or simply do not know how to answer it. No need to mention that some users are not so cooperative by providing gibberish or meaningless responses. Third, it is difficult for chatbot designers to take advantage of AI advancement due to a lack of AI expertise or resources. For example, although deep learning methods have enabled powerful conversational AI and might help address the first challenge mentioned above, such models require a large amount of high-quality training data, which are hard to acquire, especially for chatbot designers with non-AI backgrounds. Given the three challenges, in this study, our goal is to explore new ways to build more effective interview chatbots, especially with off-the-shelf and accessible technology. As a first step, we want to equip a chatbot with active listening skills, which often being used by human interviewers to make the interview participant feel being heard. Studies have shown that active listening skills can make an interviewer more socially attractive, create more engaging interview experience, and elicit high-quality responses. For example, paraphrasing is one of the techniques to actively listen. The chatbot tries to convey such understanding by restating a user's input. Another technique is verbalizing emotion, where the interviewer reflects a user's emotion in words to show empathy. Encouraging is also an active listening technique. The interviewer offers ideas and suggestions to encourage conversation. Here is a demo of an interview chatbot with active listening skills. In this study, we hypothesized that the interview chatbots with active listening skills would be more effective at conducting interviews and engaging interview participants. Given the benefits of leveraging active listening skills during an interview, in this study, we asked how to teach chatbots active listening skills. The second question we want to ask is how good are chatbots with active listening skills? We want to know how effective can such an interview chatbot be at handling complex and diverse user inputs and affecting user experience and interview quality. When designing our solution, we face many options. We use three criteria to build our prototype. First is reproducibility. We selected only publicly available technologies so other researchers and practitioners can easily reproduce our work. Second, we prefer technologies that require low resource, little training, or customization. Third, adoption. We favor technologies that a non-AI expert can use to build custom interview chatbots. In the next section, I will give an overview of our prototype. There are two parts of our prototype: GG-based system for conversation and an extension for user intent prediction. GG is a publicly available chatbot platform that has a rule-based system allows the chatbot designer to create a chatbot with a GUI, and the platform provides interfaces for conversation. The chatbot designer needs to create an interview agenda, and the generated chatbot will follow the agenda to conduct an interview. The GG platform has the ability to manage nonlinear conversations where the interviewee can go back and forth. Also, GG platform can be easily extended with third-party extensions or API. To power interview chatbots with active listening skills, the key focus of our prototype is to interpret the meaning of complex and diverse user input. In the extension, we build text classification models to differentiate user intents from their inputs. In our extension, we have a set of components to facilitate the construction of those text classification models, especially for non-AI experts. The intent classification model created by our extension is platform agnostic, which means it can be used on any other chatbot platform like GG. Our extension has a human-machine collaborative labeling component that aims to facilitate chatbot designers to create high-quality dataset for the later training. The process is progressive, where the chatbot designer can bootstrap interview data all the time to increase the size of the training data and make the later model more robust. The human-machine collaborative labeling component has an intent discoverer and a sentence ranker. The intent discoverer aims to help the chatbot designer to identify potential user intent. We use the topic modeling algorithm, LDA, to summarize a set of user responses with different topics. It is an unsupervised method, requires no prior training. Since LDA extract topics have no order, we enhance the result by ordering the topics with their coverage to help the chatbot designer identify intents that has been mentioned the most. The goal for the sentence ranker is to find examples that best match the identified intents to create high-quality training dataset. Since the extracted intents are typically summarized by a set of keywords, it is difficult to label the intents by the associated keywords due to missing context. Thus, the sentence ranker will automatically rank user responses by their semantic proximity to an intent. The training dataset is created by including high-ranked sentences as a positive example and low-ranked sentences as a negative example. Then, with the created training dataset, labeled text will be encoded using techniques like sentence embedding. Later, the model builder will take the encoded sentence to build text classification models to identify user intent. At the last step, chatbot designers can write different responses corresponding to the text classification results. In all cases, we equip a chatbot with responses that incorporate active listening techniques. Next, I will talk about evaluation of our prototype. There are two parts of the evaluation. The first part evaluates the ability of our prototype to detect user intent, and the second part evaluates the quality of a chatbot that created by our prototype with active listening skills. In the first part of the evaluation, we focus on how our prototype can predict user intent when handling user's input. The accuracy of these models directly determines how well an interview chatbot can listen actively during an interview. Here, we present the result from the average performance of best models per interview topic. We choose 4 interview topics that are often used in our interviews. There are a topic about self-introduction, a topic about participants' hobbies, a topic about their best quality, and a topic about the current challenge they are facing. Those topics are often used to build rapport and are used to elicit user responses. At the first step, we focus on improving general interview topics. We try different text classification models for each topic and select the best here. Overall, logistic regression and linear SVM performs the best. From the data, we achieved about 85% precision in differentiating the user intent. The results demonstrate that our text classification model can effectively identify user intents. The ability of predicting user intents allows our prototype to deliver correct active listening skills. To evaluate the effectiveness of our chatbot with active listening skills, we also conducted a live chatbot evaluation with end users. In this evaluation, we compared our chatbot with active listening skills with a baseline chatbot. The baseline chatbot is created by GG's base system without our extension. The participants are randomly assigned to be interviewed by either of the chatbot. We recruited a total of 206 participants from Amazon Mechanical Turk. 108 participants engaged with our chatbot with active listening skills, and 98 of them chatted with the baseline version. There are 96 female participants and 110 male participants. Most of the participants are between 18 to 34 years old. To measure the effectiveness of our interview chatbot, we evaluated from two perspectives: user experience and interview quality. The user experience includes engagement and perception. User engagement measures engagement duration and response length. And the user perception asks participants how well the agent comprehends their input, their willingness to interview by the same agent again in the future, and the overall chat experience. We believe it is a more comprehensive measure of user experience by combining both objective and subjective measures. Last, we measured response quality and the approximation for interview quality. The measures of response quality considers both volume and richness. The informativeness measures the volume of information, which is calculated by Shannon's information theory. And then we hand-coded all participants' responses and calculate the response quality index for each participant. The response quality index is adapted from prior research on chatbot survey, which considered three aspects of a user response: relevance, specificity, and clarity. More details about those measures can be found in the paper. We analyze our data by using ANCOVA analysis. Compared to the baseline chatbot, our chatbot with active listening skills can better engage the participant and elicit higher quality information. People who chatted longer with our chatbot and provided lengthier responses. They also explicitly mentioned that they feel the agent can better understand their input and they are more willing to chat with the same agent later. The overall user experience is also better. The analysis on collected responses also indicated that the participants provided higher quality responses to the chatbot with active listening skills. All results are statistically significant. As a result, we can answer our research question firmly. To the first question, our prototype system demonstrates that it's feasible to use existing and practical AI technologies to build effective interview chatbot with active listening skills. Second, our chatbot with active listening skills are more effective at engaging users and eliciting quality user responses compared to those without such skills. There are a few future directions we want to explore. First, it is important to interpret deeper user intents beyond the semantic gist of user input. Second, the chatbot in the future should be able to generate and ask follow-up questions intelligently to deepen the conversation. Third, learning the effect of individual active listening technique can better inform the chatbot to exercise the most effective technique based on the context. Our work provides three contributions. First, our work demonstrates practical approaches to build effective interview chatbots. The way we design our prototype can be used on any existing chatbot building platforms. Second, our work also provides insights for creating hybrid framework for developing progressive chatbot platforms. The chatbot designer can collaborate with a machine and algorithm to create a more sophisticated chatbot by bootstrapping collected user responses. Third, equipping a chatbot with active listening skills not only benefits interview chatbots, but also can be adapted for broader applications, such as emotional support to create empathetic AIs. That concludes my video. Thanks for watching. At the end, I would like to thank all reviewers for their feedback and the Air Force Office of Scientific Research for supporting this project. I'm happy to answer any questions you have about the paper. Please send me an email. Thank you.